everybody. Morning, afternoon, evening, as the case may be. My name is Shruti Kulkarni. I am an information security architect with Alexon, based in the UK. And my presentation today is about context-based access control. So let's start off. This is going to be our agenda for our presentation today. We'll talk about access controls, implicit trusts, how contexts help in addressing implicit trusts, the role of AI, context-based access control, and finally, we will have some takeaways for you from this presentation. I would like to start with some background. Breaches are kind of getting very common in today's digital world. And the use of stolen, weak, or default credentials in breaches is not new. It is not really rocket science, it's not glamorous, but it is widespread. So to breach a resource, one needs to have access. And a significant number of breaches start with access that is either granted incorrectly or is obtained maliciously. I would like to just take a little step back over here and then mention that, when breaches take place, the companies obviously make it to the headlines, but then there is always an impact on the users whose data has actually been breached, and that's usually public, like sometimes like people like you and me. And we don't end up on any front page news, but we do end up as a part of a statistic wherein probably our identity is stolen, or we have had a financial fraud, or we have been impersonated in some place. So that's the reason why, Zero Trust always says that never trust and verify. You always verify before granting access or denying access when an entity requests access to a resource. So that's going to be the theme generally running through our presentation today. Now, for breaches to take place, all it requires is authentication, obviously authorization, and some mistakes. So some basics over here just to set the tone to the presentation. Authorization and authentication. So authentication takes place with an identity wherein we say who we are. And authorization is based on permissions. It's generally what we are allowed to do or not allowed to do. So how does it really take place? Now, we've got an asset, because when you need access and you have an entity, there is usually a resource involved. And then you got an entity. So the entity asserts its identity and permissions to access the resource. So if you have an asset A, this is the process that's followed. If you have an asset B, the entity again asserts its identity and the permissions and requests permissions to access the resource. So here we've got a little blurb of what an entity is. When we talk about an entity, it's not just an individual as a person. We also talk about organization, devices, or processes. In other words, an entity is a human and non-human entity. And then an asset is a resource of value for an organization that it possesses or employs. People are assets, but they are employed. A server with some data on it is a resource that an organization possesses. So here is a little definition of access control from FIPS. It's actually a process of granting or denying specific requests, to information or information processing services, to enter a physical facility, etc. Now, with access control, what can really go wrong? When you have an asset and someone tries to access it, they can introduce malware, they can insert a malicious USB into an asset, they can download a compromised web server, they could escalate their privileges, and there are so many other things that can go wrong. They can exfiltrate data from this particular asset. Now, what's the impact of this compromise? Now, typically, when a malicious actor moves laterally into an organization, the direct impact is lateral movement. So they keep on moving from one asset to another, which leads to advanced persistence, exfiltration of data, introduction of malware, ransomware, etc. Now, why does this happen actually? That's because IAM is central to a lot of business assets. Like, you need identity and access management to access code base, to access data, to access an operational technology, to access a service like, a physical data center or your application. So identity and access management is central to everything. Now, we we are aware that breaches do take place. Access can be compromised, but then we've been addressing this problem for a long time now. So how do we actually do it? Typically we put a boundary or a perimeter around our assets, and we try to protect it with firewalls, with VPNs, with tools like XDRs, or even host-based intrusion detection system, or a firewall, a localized firewall on the asset. But in spite of this, breaches still take place. So one reason for this is implicit trust that is built into the system. Now, allow me to explain how this implicit trust is actually present in a system or an ecosystem or an environment. So we have been referring to assets. We have got an asset A and an entity. Now, when this entity requests access to an asset, it asserts its identity and then permissions to access the resource. Now, if you've got just one asset like asset A, that's fine, Or if you have an asset B, that is fine too. But what if you've got thousands of assets and you need to access at least 100 of them? You can't keep on asserting your identity for each of those assets. That means you're entering your username and password on each of the assets. Can you imagine the kind of confusion or the kind of overhead that can create for administrators who actually access thousands of assets if they are present on the environment? So to address this situation, usually we have got an identity provider wherein an entity connects to the identity provider, and the identity provider provides the entity with a token, bearer token, or password hash, and then the entity presents that to asset B, asset C, asset C. So, and then it requests for the permissions to access the resource. So in this process, what happens is that these tokens, bearer tokens or password hashes, can be stolen. And then presenting those tokens, a malicious actor can spoof or abuse the identity of the entity by using those stolen credentials. So the alternative to this is, again, going back and then asserting identity with every resource. But that's not operationally feasible. So to get around this problem, we can establish conditions for the asset to authorize the entity. So typically when we present a token, it is always assumed that the token belongs to the entity who asserted the identity in the first place. So it becomes a binary decision. When the entity has a token, it is assumed that the entity is also authenticated on each and every instance where they present the token. So if we replace this with a context, that is establishing the conditions to make sure that the entity that is requesting access to an asset is indeed the one that has been authenticated. So let's first talk about what context is. Cambridge Dictionary defines context as the situation within which something exists or happens, and that can help explain it. In terms of access control, context is defined as the conditions that can help elaborate the access request and explain whether the request is valid, is appropriate, and ensure that it is not fraudulent. So, Context-based access control is really not new in this world. Context-based access control has existed for quite some time now. So if you can reflect back, there used to be financial applications wherein a user who would log in to the application from different browsers wouldn't be allowed to do so. They would be allowed to log in from only one browser or one device, and any other logins would be terminated. So it's just a context based on the device that or the browser that the user was trying to access the application from. And then there is the conditional access authentication context in Microsoft 365, which is based on user and groups and IP location information, device, and etc. Then there is another one by Tally's group. So all I'm trying to say is that context-based access control is not really new in this world. But the way you consume context-based access control needs to actually keep up with the different changes that happen in this world. So we will see how that actually is done and addressed in the coming slides. So now, if you actually look at this slide over here, we've got conditional access authentication context in Microsoft M365 based on few signals and few parameters. Even you can see the same thing reflected, or a similar thing reflected in Tally's group solution as well. So, but how do we ensure that we build the right context for the users who are the entities that are trying to access control? And I did mention earlier on in the presentation that zero trust always says we should never trust, but always verify and always authenticate an entity that is trying to access the resource. So it makes total sense that we align and blend context-based access control with zero trust principles. So what we can look at is consuming signals from identity, device, network, application, and data that are the pillars of zero trust, and enable it by cross-cutting capabilities to make sure that we are pulling information from disparate sources. Now, the kind of signals that we consume are really dependent on what we are trying to do with it. My very good friend and colleague, Henny, has this diagram, and you can actually look up on it from one of our deliverables that we produced from the identity pillar of Zero Trust Working Group. It talks about the Kipling method of where, why, where, when, how, and who signals, and what those signals actually mean and how we can consume them. So really, the depth of the signals is proportional to the risk tolerance and on the risk appetite of the organization. What I mean by this is that an organization may decide that they want to consume only signals from identity and device based on their risk assessment. That's okay too, but it's good to have that context and then the framework to refer from to, and also to understand what actually suits our organization and then tailor the signals to meet the organization's risks. So that's where zero trust and consumption of signals and context-based access control converge. Now, I did talk about the signals from identity, device, network, application, data, and all. There are certain nuances when we actually consume these signals. So that's what we look at in the next slide. When we are consuming signals from network pillar, we've got IP addresses. So people actually travel when, during work. Like, for example, I use my laptop in the office, and I may decide to work on the train on my way back home. So when I log into my office network from my laptop, I would have one IP address. But whilst I am actually traveling on the train, my IP addresses would change depending on the wireless that is available on the train, depending on the mobile network that you would use. So it is very important to consider all these factors as well when we are trying to consume signals. Like, IP addresses change when users travel between cities. They may switch between devices within an environment, and they may decide to work at odd hours. There may be blade crash scenarios as well. So we need to consider all these parameters and these nuances when we are designing our context-based access control. So here are some of the challenges that one may face while designing and using CBAC. So we decide to consume signals from the pillars, but then there could be operational overhead, there could be performance issues, there could be time lag to process signals, and there could also be an incorrect access denial or a false positive, as we would like to call it. And can we address this? Yes, definitely. So one way to look at this is to have various user categories and then do a pattern, access path pattern, and then work on a context and then decide on the response. So for example, if we have got an administrator in the environment and a user category, so these can be two different categories of entities. The administrator may, while accessing different devices, they may take a path from A to B to C 90% of the times. 10% of the times, they may decide to take a path from A to C, which could be okay given the context. Similarly, a user may take a access path from A to B to C 99.9% of the times, but 0.1% of the times they may take a path from A to C. So when the administrator is taking a path from A to C, or a user is taking a path from A to C, how do we know that the user is indeed the same user who takes the access path from A to B to C 99.9% of the times? So here is where you may want to decide a confidentiality level and then work out a maximum probability that is required before a concern is raised. For example, that could be 2%, depending on your organization's risk stance. So this is one way to look at it. CBAC, we can consume all the signals at the same time, but this could lead to operational issues. Or to make sure that we are using proper access paths and also addressing any kind of challenges with CBAC, we can look at it slightly differently. For example, if an administrator usually logs into a DNS server from the office network on a managed device, that is termed as a normal access pattern, that is your A to B to C 90% of the times. On the other hand, if an administrator logs into a DNS server from a home network on a managed device, this is an anomaly or a deviation. But it could take place because of an emergency or an operational signal due to a operational outage scenario. Could be either of them. So what one may want to do is, the context is built now, but then because there is a deviation, we consume additional signals. Like, for example, the time of login when the administrator logs into the DNS server, for existence of a session in the office network. And if both of them do not display any risks, then a step-up authentication can be requested to make sure that the administrator's credentials are not stolen and then they are still the same person who has requested the access. So that way we can address the access paths as a part of a context, and also make sure that we are addressing operational overheads or any other CBAC challenges. So then we allow or deny based on additional context attributes. So this is what we mean when we talk about access-based, context-based access control. We check for statistical anomalies in the typical access path, followed by user categories. And we introduce a concept over here that is using AI to process signals. So this is a concept we have not talked throughout this presentation, but we would like to introduce that. That is because we live in a world of increased digitization of business processes. As a result of this, we see a really high velocity of signals. We see a high volume of signals coming into the environment. And then we've also got to make sure we are reducing delays in any kind of access grant or access deny for any access request that is placed. We also need to make sure that we are more aligned to pattern matching and behavioral analytics to make sure that the user is indeed the same user who has requested for the access and they are not from stolen credentials or implicit trust. That is where AI actually comes into picture. And we think AI will really support context-based access controls by providing a better way to match the patterns, to determine user behavior, and to make sure that we narrow down the anomalies, or rather the deviations. We really detect the deviations and narrow down any errors when we are detecting the deviations or addressing the deviations. So now, having said all of that, and then we have talked about context-based access control, any system, as we know, requires improvement. If we think that we have built a system and that is perfect, well, that usually doesn't take place in real time, in the real world. Anything and everything can be improved upon. And it holds true for CBAC as well. So we talked about consuming signals from zero trust pillars and using those signals to determine whether the access that has been requested is genuine or not, is from the intended entity or not. So as a part of that, because zero trust is based on policies, policies can consume static attributes like device ID, application ID, etc. And then we can also consume dynamic signals like network and geolocation, which change, the device health, which changes because you may have malware on it, and an operational status of application or the resource being accessed because, for example, we saw that in our administrator's example, when an administrator tries to access the DNS server from home because they have, they have reached home and the application went down when the administrator was at home. So please don't think that these are the only static and attributes and the dynamic signals you can consume. These can change depending on the organization that you've got, on the type of assets you've got, the applications you've got. But all I'm trying to say is that your policies are typically driven by attributes and signals. It's up to you how you mix them and match them and combine them to make sure that you address your organization's needs, your risk status, risk stature, and also the operational overheads. So AI supports the behavioral analytics for contextual risk-based analysis of signals, attributes, and roles in the policy enforcement point for access decision-making. And when these are all consumed as a part of the cross-cutting capabilities in terms of visibility and analytics, automation and orchestration and governance, please do refer back to the initial slide when we talked about context-based access control and zero trust, and then the cross-cutting capabilities supporting the 5 pillars. So when we consume the logs as a part of the CBAC feedback loop, then we can actually determine how many accesses were granted or denied based on the access patterns and the shifting threat landscape. That will give a good insight into user behavior analytics or any kind of a new development. For example, someone logging in from 2 places, from 2 different countries on the same day, and then that can feed back into your policies so you can refine your static attributes and your dynamic signals and reduce the number of errors that when addressing anomalies and your deviations. So this is what called the feedback loop. All this information is based on the research that we conduct from our Zero Trust Working Group's identity workstream. You can actually, the context-based access control document is now out for public review. So go ahead, take a look at our document. It has a lot more information about about the differences between RBAC, ABAC, and CBAC, and also it has got a maturity model for how CBAC can be implemented within the organization. And we have also got some examples of organizations that use different flavors of CBAC, and they have used that to build products which end users consume. So to conclude, the use of stolen, weak, or default credentials in breaches is not new, but it works. And breaches happen, they happen. It could be due to entities who are outside the organization, and it could be due to entities who are inside the organization. And insider threat is prevalent, and we do hear a lot of news and information about insider threats. So a significant number of breaches start with access that is granted incorrectly or obtained maliciously. And the point is, these kind of breaches take place, and one of the reasons is implicit trust. We did talk about how implicit trust gets, is present in an environment, and it's because when credentials can be stolen, identities can be spoofed, identities can be abused. But then when an access is granted to an entity, that is not checked. So context-based access control seeks to address that implicit trust by making sure that the entity that is presenting a token or a password hash or anything that the organization uses, to make sure, and the context-based access control actually helps in making sure that the entity is authenticated, or at least it is checked that the entity that is presenting the credentials is indeed the one that is authenticated. So, sorry, I think I'm going in circles now. All I want to say is that context-based access control consumes ZT's principle of never trust, always verify, and it helps reduce implicit trust by verifying the entity, by authenticating it if any anomaly is detected or if any deviation is detected in the way the entity accesses a resource. So tracking malicious activities and continual validation using multiple signals and statistical anomaly is what context-based access control provides. And AI can be used to make sure that proper patterns are recognized and behavior is analyzed. So context-based access control cements the security principles of comprehensive visibility, least privilege access, and continuous risk-based evaluation and authentication, aligning to the principles of NSTAC as it is presented in the document. I think with this, I will conclude my presentation, and I'm more than happy to take your questions if you have any.